Hi, hello everyone. Yeah, we are on the screen. Let me just full screen up. In this video, we are going to get an idea about what exactly is machine learning. We are slowly going to get an introduction, a brief, short, but descriptory introduction to machine learning, and what exactly is it? How does it work? Okay, uh, yeah, right. So as we can see, like on the slide, it says that question first arises is that what exactly is machine learning? What is the need of the machine learning? What is it? So we all know a buzzword named artificial intelligence. We all know what AI is. So if someone has to describe what AI is, AI would typically mean it's a sort of a type of intelligence, but not the natural intelligence that we humans or any sort of living animals in this world have. It is something referred to as artificial intelligence, an intelligence which is being created by the humans, which is some logical piece of code, some logical set of instructions through which in some context of information which is being fed to the machines, being fed to the device, and based upon that piece of code which is being devised, which is being formed by the humans, the machine is able to learn some patterns. Okay, it never has the intelligence we humans have. It always has some pattern, some distribution that it picks up, and based on that distribution, it does things which looks intelligible to us and which is actually intelligible because it is able to do things quite accurately and quite the same way that we humans do. And after that, deep learning has come. It's more closer to the way we humans do and we humans process and understand things, because we humans in our brain do things with the help of neurons, and deep learning also uses the same concept of neurons to do things now using the deep learning technology. So let's now first understand the what exactly is machine learning. So machine learning is basically a subfield of artificial intelligence where our main perspective is to write programs, intelligent program having statistical and mathematical portions in them, which let the machine learn patterns and learn things so that they can do work without intervention of human. Okay, so without human intervention, it is able to do intelligent tasks like identifying something, predicting a particular stock price of a stock company in a certain year, predicting if a certain image of a plant is affected or not. Is that plant having a disease or not? Such kind of applicabilities and various other huge applications are there for machine learning, which we are going to cover later. So now we understand what exactly is machine learning. Let's get to what types of machine learning we have. Just get an idea about it. So generally machine learning in all of it is only composed of three types as we know of now: supervised, unsupervised, and reinforcement. So supervised learning is that you show the machine learning algorithm a lot of labeled data. So what we mean by labeled data, it's like showing pictures of just consider the example of plant disease. So basically show a picture of a plant to the model, and then it says me if my plant is affected or not, and by which disease it is affected, right? So the data which I'm going to feed, if it is a supervised machine learning algorithm, data which I have to feed is always a labeled data. When we say supervised machine learning algorithm, that's a labeled data. What do we mean by labeled data? A data where we have the input and the output both given to the machine, to the model. It's like I'm showing a picture in the training phase when my model is learning things. I'm showing it the picture, and I'm also saying it if it is affected or not, in what disease it is affected. Okay, so I show it like 10,000 images of plants, and then I tell him that and I'm also telling him it is affected and by which disease it is affected, right? And after this, it learns a pattern. That is what supervised machine learning is. I am telling him first how things are happening. If I showing him a picture of plant, and I'm also telling him that what disease it is affected by. Next comes the second category, which is the unsupervised machine learning. Now, the word, the name intuitively tells us that supervised was like I'm supervising the model. I was telling him what exactly it is. But in unsupervised machine learning algorithm, I just show him the data and I don't show him the output. It's an unlabeled data. It's like I show him the images of plants, but I don't tell him at the first phase if the plant is affected or not. And in that way, based upon unsupervised machine learning algorithm, picks a pattern from that. And then when I show him a new picture of a plant, it would say me to what category it belongs, affected or not, even without giving it a label classification. And finally, we have reinforcement learning. Reinforcement learning is a different paradigm of machine learning algorithm, where a model performs things on its own and it receives output, it receives input from the environment based upon how it works. So consider an example of a lunar lander. Like a lander is there which lands upon Mars, but a lander cannot land anywhere. It needs a certain geometry of the surface on which it is going to land, a certain smoothness, certain texture of the surface on which it's going to land in order to have a good landing, a proper landing. Because in such scenarios, when it is too far away from here, we cannot manipulate the spaceship manually by ourselves. So everything has to be done by the uh, lander itself. So it has to understand where should I land so that my landing is best. So this is where reinforcement learning is used. Based upon its performances, previous performances, it was rewarded. If it landed in good places, it was given a better reward. If it performed poor, it was given less reward. So based in that reward and action, it understood what I have to do in order to get a better reward. That is what reinforcement learning is, right? So these are like the only majority of the three types of machine learning that we have: supervised, unsupervised, and reinforcement learning. Right. So next comes the question is that why we are saying machine learning? Why is learning being used? Learning is like to learn something, to understand something. Why we are saying machine learning? Do a machine basically learns, reads something? So the answer is yes. Our machines do learn, but how it learns? So the major framework behind how machine learning work, machine learns, is the statistical algorithms that we put in, mathematical and statistical algorithms that we put in. Based on these algorithms and based upon the data that we feed on the model, it is able to understand some patterns in the data. It's like showing huge number of images to a model. It is able to understand what is exactly in the image that I have to understand. Okay, it's like pretty simple. When we were a child and we are being shown images of certain fruits, at first when a child is born and he's being shown some fruit, he's not able to identify what it is, but as slowly he sees more and more fruits and slowly he learns a pattern, how an orange looks, how a mango looks. And then when you say the child, like say, what is this fruit, and he is able to tell that's a mango because he has learned the pattern. So similarly, machines, by the use of that statistical algorithms that we are putting in its code and we're feeding that huge amount of pictures, it is also able to likewisely understand the pattern which is residing in it, and then it is able to understand and classify what fruit it is, what image it is, what disease the plant possesses. So it goes like this. So yeah, machines do learn, but they learn differently from human beings. They do algorithms to learn, and they need a huge amount of data to learn. Okay, now comes the question: what are some of the use cases? So machine learning is a very common word nowadays. So let's understand what are the use cases of machine learning. So I've listed some of them. Healthcare is there. In healthcare, we do medical imaging, predictive analysis. We have finance. So in healthcare, like you can have machine learning algorithm, and you can have algorithm which sort of predicts what sort of tumor a person has based upon his MRI scan. And then you have finance, the usual stock prediction analysis, stock price prediction. Then you have retail, you have recommendation systems. As we all know, Amazon, YouTube, based upon the content that we see, the content being suggested to us is dependent on our seeing habits, on what kind of content we like. Such contents are being recommended to us. That is entirely managed by recommendation system, which is a complete application of machine learning algorithm. Then we have transportation, we have route optimization. Then finally, we have natural language processing. What exactly is natural language processing? This is a very, like in itself is a big topic. So natural language processing is again a part of artificial intelligence and machine learning, which deals with understanding human or any natural language. So this language with which I'm speaking with you right now is a natural language, a human language. So this has to be understand to the computer. Computer has to understand this language, but cannot understand it directly. It has to understand it by some framework in between. That is natural language processing. Various techniques that we use to make the computer understand our natural language is natural language processing. Okay, so now at last, after giving info about all of this, I would finally show you one live application of machine learning. For that, I would just leave from here and open a new Jupyter library. Jupyter notebook. Just open another one. Just open this folder. Yeah, it's here. So you just don't need to worry about the code written out here. I would just run this program. Yeah, it's good. It's good. Right. So this is basically, a digit classification model. It uses machine learning algorithms in its background. So what it is exactly, and now presently here I have a drawer, a drawer. I can draw things out here. Basically, it is made to draw digits. So you can draw any sort of digits out. You can draw anything, but so let's now start with it, right? So just draw two. Great. And clear would basically clear this window. And when I say predict, when I click predict, it gives me that the predicted digit is 2. Okay, now let's try with something other. Let's try with the 4. And that predicts a 4. Let's try with, 0. That predicts a 0. Let's try with 1 again. That's a 1. Let's try with a 5. It's like 5. Okay, that predicted a 7. There's one error. Let's try 5 again. And this time it's 5. So you guys are getting some idea how it's working. Let's try 7. That's a 7. Okay. So in majority of the cases, it is able to predict correctly. So let's come back to the original one. Yeah. So exactly what was the project doing? The project was able to identify what digit I was drawing, and it was correctly identify in most 99% of the cases. The digit that I draw, it was able to predict what exactly that digit is. But it was a simple handwritten digit. It wasn't a printed digit. It was a handwritten digit. You can draw handwritten 5 in 1,000 and 1 lakh number of ways, but the model would be able to say that it is a 5. Okay. So suppose you had to make a computer program, which would be able to identify this. Okay. Problem is that the number of ways I can write a 5 in a handwritten way is 1 lakh number. I can do very slight variations here and there, and I can write a 5, simple 5, which would be a 5 in 1 crore number of ways. So in that case, the program would be so big because it had to understand for each and everywhere the writing can have a variation. A general normal programming language would have to consider everything. Okay, a single variation from the way we have programmed would give us a programming error. But this is where the beauty of machine learning programming lies. Machine learning programming, instead of programming everything critically, here it understands the patterns of the images. So let me give you some context about how that model was working. So it was basically a digit classification model, and it was trained upon the MNIST dataset. Okay, so MNIST is basically the Modified National Institute of Standards and Technology, which is that MNIST dataset is basically a collection of 70,000 images of handwritten digits. So I initially had a data of 70,000 handwritten digits. Okay, it was a labeled data, just like I have a handwritten digit 5 and it's labeled that it is a 5. So it was a supervised machine learning algorithm, as I said previously. So I fed that data to a classification algorithm. There are various kind of classification algorithms that you can use, KNN and artificial neural network. So I basically used artificial neural network for this, and I fed this data to the artificial neural network, trained it, and then it was able to understand the pattern which lies in predicting a certain handwritten digit as 5 or 6 or 3 or 4, and use this model in the backend, got the image as I had drawn it, passed it through the model, and then predicted which digit it is. So this is a very basic example of something referred to as computer vision. That is how a computer is able to see things. It was like the computer was able to view the handwritten digits that I was drawing. It's called computer vision. So computer vision is basically this subsection of machine learning where the computer uses machine learning techniques to leverage image processing and image classification things. So with this, I would like to end the video. Hope it was interesting. We got to learn something about machine learning, And at the end, we had a demo of machine learning applications. Hope you all enjoyed it. Thank you.